Pause this video for 3 seconds and close your eyes. Go on. Now open them. In that tiny moment, billions of tiny sensors in your eye just switched on. Stay with me, because in a few minutes you'll see how they do it, with super simple diagrams. By the end of this video, you'll be able to sketch a simple map of how your eye turns light into signals your brain understands. No complex biology words, just clear shapes, colors, and easy steps you can remember. Maybe at school someone showed you a messy eye diagram full of tiny labels. You nodded, but didn't really get it. Today, we throw that away. We'll rebuild the eye with just a few clear, simple shapes that actually make sense. Let's start with the big idea. Your eye is basically a light catcher, like a small, soft camera, but we'll draw it as one clean circle. Light comes in, gets bent, hits the back wall, and that's where the magic really starts. We'll zoom into that back wall, called the retina. For now, imagine it as a flat, colorful carpet of tiny dots. Each dot is a light detector waiting for a photon, a tiny packet of light energy, to bump into it. Two main types of dots live on this carpet: rods and cones. Rods help you see in low light, cones help you see color. To keep it simple, we'll draw rods as blue rectangles and cones as red triangles spread across the retina. Picture walking into a dark room. Your rods start doing overtime. They don't care much about color. They just shout, "There is light!" We'll show rods lighting up first as we dim and brighten our simple diagram. Now imagine a bright, sunny park. Your cones wake up. They help you tell red from green, blue from yellow. On our retina carpet, the red triangles start to flash in different colors when light hits them from different directions. So how does a single photon wake up a rod or cone? Inside each one, there are special molecules that change shape when light hits them. We'll draw them as tiny keys that twist when a yellow light dot arrives. That tiny twist starts a domino effect. One key turning triggers a chain reaction that amplifies the signal. We'll show a line of dots inside the rod lighting up one after another, turning a tiny hit into a big, clear message. Once the rod or cone is active, it sends an electrical signal. Think of it as a little spark traveling along a wire. We'll draw a short arrow leaving the rod and heading toward the inner layers of the retina, like a message being mailed. But the retina isn't just a flat screen. It's a mini computer. The signals first pass through helper cells that clean, combine, and compare them. Our diagram will show a network of simple circles passing signals forward like a relay team. These helper cells can sharpen edges and detect patterns. For example, they tell your brain, "Here's the border of that object." We'll animate one bright bar of light and show how only certain output cells light up at its edges. Finally, all that processed information is packed into the optic nerve, a thick cable carrying signals to your brain. In our simple drawing, many small lines from the retina join into one bigger yellow cable heading toward a brain icon. Here's a key idea. Your eye doesn't send pictures, it sends coded signals about light and contrast. Our diagram will show the original scene as blocks and the signals as lines of pulsing dots, like a simplified barcode for vision. Let's walk through the whole journey with one simple dot of light. First, it enters the eye. We'll animate a yellow dot traveling through the cornea, through the lens, bending and landing on one cone on the retina. When that dot hits the cone, our tiny keys twist, the domino lights fire, and a signal leaves the cone. We'll show each step lighting up in order so you can almost see the invisible conversation inside your eye. Next, the signal meets others in the retina's network. Some signals get boosted, some reduced. The output pattern changes depending on where the light lands. Our diagram will show two cones hit and the pattern shifting below them. All these combined signals flow into the optic nerve as a steady stream. We'll draw the nerve like a moving conveyor belt of dots, each dot carrying how bright and what color information from a tiny patch of your world. Your brain then decodes that stream and builds the picture you think you see. We'll keep the brain simple, just a cloud that lights up in a pattern matching our input blocks, so you see how signals turn back into shapes. Let's connect this to something you notice daily. Stepping from bright sunlight into a dark hallway. At first, you see almost nothing, then slowly more details appear. That's your rods adjusting their sensitivity on our retina carpet. We'll show this by sliding a light-to-dark bar over our rods and cones. As it moves into darkness, rod signals grow, cone signals shrink. A simple side graph will rise for rods and fall for cones to make this super visual. Another everyday moment, looking at a colorful screen. Your cones work hard there. In our diagram, each pixel of the screen will send red, green, or blue light beams to different cones, which respond according to their favorite color. To keep everything clear, we'll animate a zoom out, from one cone to a patch of retina to the whole eye, to the optic nerve, and finally to the brain cloud building an image. One smooth chain, no jump cuts, same style all the way. Now why diagrams? Because if you can draw it, you truly understand it. I'll guide you to sketch your own ultra-simple eye. One circle, one lens, a stripe of rods and cones, one nerve cable, and a tiny brain cloud at the end. As you draw, imagine a single photon taking the journey you just watched, entering, bending, hitting, triggering, traveling, and finally getting read by the brain. That story is what turns a doodle into a powerful mental model. To lock this in, we'll replay the entire path in a clean labeled overview. Light rays, retina carpet, rods and cones, network, optic nerve, brain. Each part will light up only when it's that step's turn, like stations on a train line. Now you know how the eye detects light, not as magic, but as a clever chain of tiny switches and signals. If you want a part 2 with simple diagrams of how we see motion or depth, tell me in the comments what confused you most today.